All right, creating pinning charts for Sargent 6300 large format interchangeable cores. These cores are very, very easy to service. It's very, very easy to create a pinning chart for these out in the field, in the shop, wherever. If you're at all familiar with small format interchangeable cores, or maybe Corbin Russwin's large format core, then the process to not only pin and service the 6300 is going to be familiar to you, but also the process of creating a pinning chart. Now, I've included a link in the video description to the chart we're going to be working with today. It's actually an article with more information about the 6300, things like things you need to keep in mind when you're selecting key biddings for these cores, information about the hollow drivers that are now being used in these cores, and links to other tools, things like a decoding chart, this pinning chart, obviously, the key bidding specification that's used by these cores, and even a link to Sargent's one-page walkthrough that will show you how to create a pinning chart for these cores. That, for example, is a full page, and if you watched the small format video, you know I kind of like to simplify things. So rather than an entire page, we're going to be able to take care of this pinning chart in literally 4 rows, 4 rows, 6 columns. So a lot less work involved this way as opposed to the way the manufacturer teaches. Not that there's anything wrong with that. One thing that I will say, in addition to showing you how to create this pinning chart, that's probably best served here as opposed to the article, although I do mention, is the design of the core itself. Sargent 6300 cores utilize a control lug only in the 3rd and 4th position. Small format, it's either 6 or 7 positions or chambers, depending on the type of core. But Sargent, it's only going to use 2 in the 3rd and 4th position. The 1st, 2nd, 5th, and 6th positions key up in a conventional manner. You don't have to worry about build-up pins or formulas or anything like that. And in fact, if you look at the pinning chart I've got here, I've got those areas blacked out so you don't have to worry about them. So what we're going to do is I'm going to show you 2 ways, or 2 scenarios, I guess. First is just a change key and a control key. And then in the second example, I'm going to show you how to include a master key into that. So it's not hard at all. And again, I'm repeating myself, but if you watch the small format video, the method I used in that, it's going to be very similar. In fact, almost identical, with the exception of the formula I'm using to get to the top pin. And that I used the value of 13, and this one I'm using 12, and I'll show you that in a bit, but very similar. So if you're already familiar with that, you can create pinning charts and service Sargent 6300 cores. It's that simple. So first we're going to start with a change key and control key only, no master key. So right off the bat, we can go ahead and run hyphens through the master key pin portion because we're not going to use those. And then just as if we were accommodating a conventional cylinder or a small format core, or any core for that matter, the bottom pins are going to correspond to the change key biddings. So our change key is 361605. Very simply, all we have to do is transpose those digits up here for the bottom pins. Now, I guess one thing to keep in mind before we get any further, Sargent, a 0. Schlage, for example, depths biddings go 0 to 9. Sargent goes 1 to 0, with 0 being the deepest cut and the largest bottom pin, 1 being the shallowest and the smallest bottom pin. Some people commit to memory by just treating the 0 for Sargent as a 10, which is what I do. And it helps you kind of keep things in perspective, because if you put a 0 bottom pin, well, number one, they don't exist. But if you try to keep that in mind conventional ways while creating one of these pinning charts, you're going to mess yourself up. So before we go any further, just if you already don't know that, commit that to memory, because when you're creating these, you don't have a pin kit in front of you to know that there's not a 0 bottom pin, or there is, but it's not a shallow pin, so it might trip you up. But we've already transposed the bottom pins as they correspond to the biddings of the change key. And then, very similar to small format, The 6300 has a uniform stack height. With small format, it's 23. For Sargent, there's two different values. Non-control chambers have a uniform stack height of 15. Control chambers have a uniform stack height of 20. So we just have to keep that in mind while we're making these pinning charts and pinning them up. So if we only need to figure out the top pin for these non-control chambers, because we obviously don't have build-up pins, and we know one of the two values, we simply have to subtract the known value from 15 to tell us our top pin. So 15 minus 3, that's a 12 top pin. 15 minus 6, it's going to give us a 9 top pin. 15 minus 0, or 10, 15 minus 10 is going to give us a 5 top pin. And then 15 minus 5 will give us a 10 top pin. So we're already 2/3 of the way there. Next, we're going to figure out the top pin, just as I do in the small format video. And the way that you determine the top pin is you take the number 12 and subtract from that the corresponding control key bitting for that chamber. So for example, 12, well, in this third chamber, the bitting is 7. 12 minus 7 is 5. So that's our top pin. Going to the fourth chamber, 12 minus 4, 8. So that is our top pin for the fourth chamber. And just as we did for the non-control chambers, we know 2 of the 3 values necessary to create the pinning chart. So very simply, we'll add these 2 up. 5 and 1 is 6. Well, we know it needs to be 20. So 20 minus 6 gives us 14. Moving to the fourth chamber, 8 plus 6 is 14. 20 minus 14 gives us 6. And that's the pinning chart. That's how quick it goes. Again, the article is going to cover special things. It's going to have a key bitting specification that'll show you the increment values. For this, it's 20,000ths of an inch, all Sargent 6300s. But if you're not familiar with it, it's all there. So next, we'll move to a master keyed pinning chart to show you kind of how to walk through that. And as I said before, just as with small format or Corbin Russwin or whomever, the bottom and master pins are going to be determined in the conventional manner. So in other words, the shallower or smaller of the 2 numbers is going to determine the bottom pin. So if we've got a 5 and a 3, the shallowest is going to be 3. Then we subtract the difference, largest from smallest, or smallest from largest rather, and that gives us 2. So we're going to do that all the way down through all 6 to give us our bottom and master pins. We've got 6 and 8. 6 is the shallowest. Difference between 6 and 8 is 2. 1 and 3. 1 is the shallowest. Difference between 1 and 3, again, 2. 6 and 8. 6 is the shallowest. Difference between 8 and 6 is 2. And now here's where it can trip you up if you don't do Sargent often enough. Anywhere else, we'd say 0 is the shallowest cut, and the difference would be 2, so it would give us a 2 master pin. Not the case here. Remember, we got to treat these like 10s. So 2 is obviously going to be the shallowest of the 2 cuts. The difference between that is going to be 8. And then finally, 5 and 7. 5 is the shallowest. Difference between 5 and 7 is 2. So very simply, we've got the bottom and master pins taken care of. Now let's move back to the top pins for the non-control chambers. Remember, we've got 2 of the 3 values we need. So if we know it needs to be 15, we simply add what we know and subtract from 15 that number. 2 plus 3 is 5. 15 minus 5 is going to give us 10. I guess I could have wrote that a little bit better. 2 plus 6 is 8. 15 minus 8 is going to give us 7. Skip over the control chambers. 2 plus 8 is 10. 15 minus 10, 5. Finally, 2 plus 5 is 7. 15 minus 7, 8. Okay, so now we just have to focus on the control chambers. Same formula as before. Adding a master key or multiple keys doesn't change that at all. 12 minus the control key bitting will give us the top pin. I'm using the same control key as before in the last example, so just kind of repeating the point so you kind of get it. So for the third chamber, we've got a 7 bidding in the control key. 12 minus 7 is going to be 5. And then we've got a 4 in the fourth bidding. 12 minus 4 is 8. Now we need to figure out our buildup pin. Well, again, we've got 3 of the 4 known quantities. Let's add them up and then subtract from what it should be, 20 in this case, to figure out that missing buildup pin. 5 plus 2 plus 1 is 8. 20 minus 8 gives us 12. 8 plus 2 plus 6, 16. 20 minus 16 is 4. And it's that simple. I know a lot of people shy away from interchangeable core work because maybe they don't know the formulas, or maybe they think they're a little bit more daunting than they have to be. And looking at some of the manufacturers' pinning worksheets and formulas, I can agree with that. They are, I don't know, a little obnoxious, a little bit more complicated than they have to be. But when you keep these little shortcuts that I've learned, I've taught myself, learned from others, other people have discovered, you're going to find that it's a lot simpler than they need to be. And I'm just going to throw this into perspective so you're not just looking at cardboard. This is the rest of the pinning chart. It's got the combination rules as well as the bottom pins and the build-up master and top pins. But going back to what I said, these don't need to be hard or daunting. You don't need to be intimidated by them. It's incredibly easy to create pinning charts. They top load just like small format and Corbin Russ one. So drop your pins in once you got an accurate pinning chart, put your springs, put the slide cover, stamp it into place, test your keys, you're good to go. Very lucrative work. There are a lot of Sargent large format interchangeable cores out there. In our market, Atlanta, for example, the brand new stadiums they just built here, the Mercedes-Benz and SunTrust have Sargent large format, have the 6300s all throughout them, hundreds of cores. So very popular. Small format's not the only game in town, so it would behoove you to kind of learn all possibilities out there. So with that said, like I said, I'm going to put an article in the video description. It's going to give you more information than just this, but I find that certain things lend themselves best to video demonstration and some things best to text. So the purpose of this video was kind of to show you how to create those pinning charts using the method that I use. Not the only method, but the one I prefer, and it'll show you how to create a pinning chart in seconds. Thanks.